All right, so I have my screen shared now, and I just want to show you what's up with the Canvas website. So when you enter into Canvas, this is the home page that you should see, I believe. I put up the taped Zoom session from Monday right here. So in case you missed that session or you want to use it as a device to sleep soundly at night, you can listen to it then. But it takes, I just wanted to let you guys know, it takes about, it took overnight to process on YouTube. So what I have to do is I take it from the Zoom website, download it, upload it into YouTube, and then it processes it, puts closed caption on it, and then I can click a few more buttons, give it a title, and connect it to the canvas. So it takes time to process, and it's not just me, it's YouTube. But I should have it up within 24 hours. All right, so here we are. That's where you're going to find today's discussion. And we went over some of this stuff here. Now, here's our assignments tab. So I want to click the assignments tab. And we'll talk about the pre-lab techniques quiz next week. It's not so important right now. Here's the electronic spreadsheet and computer graphing lab. And in this part, we have a pre-lab quiz. This is designed for you to take after you read through the lab manual. So you don't have to understand everything in the lab manual completely and know exactly what you're doing before you come to lab, but you should, read through it. If there's some definitions that you don't remember, then you can look them up and try to kind of get a sketchy idea of what's going to go on in lab. Now, I wrote these quiz questions. For this one, it's only 3. And I wrote them to try to pinpoint possible weaknesses in student understanding that I've seen in the past. All right, so this first question for the quiz, it says, the pH of a 15.25 molar solution of H plus is, so what's the pH of this acidic solution? And it gives you the equation for calculating pH. It says the pH equals minus the log of the concentration. So all you need to do is take the log of 15.25, and that's your answer. But you'll notice it's all the same answer down here. It just has different significant figures for each one. So you have to look up the propagation of significant figures connected with taking the log, whether it's log or ln, it's the same rules. So when you look that up, what you'll find is that when you take the log of a number, it becomes this beast that's no longer considered a number. It doesn't even have units anymore. This beast is made up of essentially 2 parts, a character and a mantissa. The character is to the left of the decimal point. The mantissa is the right. The character is a power of 10 placeholder for log, and the mantissa, the number of digits to the right of the decimal point, that is where your significant figures lie. So if I take the log of 15.25, I notice that 15.25 has 4 significant figures. And according to those rules of character and mantissa, the mantissa of this first value has 5 after the decimal. This should only have 4. Remember, to the left of the decimal is the character. That's the power of 10 holder. So this is somewhere between 10 and 100. That's why it's 1. Okay. So anyway, this isn't the right answer. This one represents the one with the right number of significant figures. Okay. So this question was designed for you to learn about the character and the mantissa and the propagation of significant figures when you take a log. And so forth. So, you know, you can check these out. Remember, this isn't going to go directly to your grade, but understanding these will help you prepare your report properly so you don't get points off then. All right, so that's all I wanted to say about that part of this first assignment in electronic spreadsheet and computer graphing. Any questions on that? All righty. Now, the next part is the Excel file that you'll need when you work up your report right here. And if you haven't had a chance to pick up the lab manual or have the bookstore send it to you, you can download that portion of the lab manual right here. So this is copied right out of your lab manual and it's put there for your viewing pleasure. Over here, I have a video that kind of connects the things that you're going to have to do for that report to this video. So it kind of helps you out if you check it out. But I'm going to go over in some detail right now. And I'll post that video by tomorrow, and it'll essentially take the place of this one. Any questions so far?
Where do we look up the definitions for that ESCG quiz? Is that just in our text?
No, I don't think it is in your text. You'll probably have to get a definition online.
Okay.
It's a math kind of a concept.
Got it.
But it's essentially what I just said. So, you know, you get two things when you take a log of a number. You get a mantissa and a character. The mantissa, the places in the mantissa tell you how many sig figs. The character tells you the power of 10. And so, all right. So I want to take a look at the assignment, and the way I'm going to do that is to just open a file here that corresponds to the spreadsheet that you have to download. Okay, so this file here is a copy of the lab manual. So this is what you could download from Canvas. This is the first, this is page 1 of the lab manual. Okay. And so you go through this and you go through the tutorial. And the tutorial covers the first 9.5 pages. And in that tutorial, it shows you how to use Excel to enter data, to calculate data based off of that, to make plots, to fit those plots to lines, to represent the line with a mathematical equation and so forth, right? So that's all in here, and you can practice, and none of this is going to be handed in. So if you know, if you're an Excel expert, then you don't have to do it. Just go right here to the assignment. Okay. Now, here's your assignment. And I want to go through 1, 2, 3, 4, 5, 6, and 7 with you. And then I'm going to stop because 8, to address 8 for your assignment, you should know something about integrated rate laws. And in lecture, you probably haven't had a discussion. In my lecture, we're probably going to discuss it on Monday. We're going to get to integrated rate laws. And so once we get to that, then you'll see, oh, okay, I understand what I have to do for 8. So what I want to do today is just 1 through 7 and show you how to do that report. Any questions on that? All right, no questions. Good. Okay, so this file that I just opened, can you guys see this?
Yes.
Okay,
Yeah.
cool. Just checking to see if you're awake and you passed. This file is the one from Canvas. This is the file that you have to work up and turn in as your report. So if you have your lab manual, then on page 9 of your lab manual, number 1 is, well, what we're going to do first, because that's what you have to do for your report. If not, it's in that file that I just closed. Okay, so number 1 says, enter your name in cell A1. So you can put your name up there in A1. Enter your class number here. And our class number is 82207. And so you are done, almost done everything in number 1. Number 1 also says, adjust the time column to assume that the time measurements are to the 10th of a second. So here's some experimental data that you're given. You don't know where it comes from or how it was done. You just assume that it was done correctly. And that what they want you to do is adjust the time column here to the 10th place. Add another significant figure, in other words. So what you should do to do that is just select the number. If you select the titles, then Excel gets confused oftentimes. And this goes with plotting too. So whenever you want to just do something to the numbers or make plots, then just select the numbers and not the titles. And that'll save you a lot of headache. But anyway, with Excel, I can select those numbers, go back to home, and then use these buttons over here to add decimal points or take decimal points away. So if I click this button, it adds a 10th. And that's what the directions want me to do. So now I'm done number 1. Any questions on number 1 for your report?
You said 82207 is our number?
Yes, 82207, correct. That's just the class, the course number. Yeah. All right, any other questions? So we're good. All right, so number 2, it says complete the spreadsheet using the appropriate formulas, center titles, and make sure you have the right number of sig figs, blah, blah, blah. All right. So it wants us to finish these columns right here, these generated columns. I need to take the log of the concentration, here's the concentration, and 1 over the concentration to generate these columns. In Excel, that's very easy. To do this, I just click my cursor here in that first spot and put in an equal sign. As soon as I put in an equal sign, Excel gets excited here. It knows I'm going to be putting in a formula. I want to put in the log, ln. So I put in L next, and Excel's trying to help me out. What do you want to calculate? Large, LCM? What are you up to? And so I can see down in the list, oh, this is the one that I want. So I can click on it, or I can continue to type ln. Now I'm down to one option. Okay, good. That's the one I want. So I double click on that. And it says, okay, Now, which numbers do you want to take the log of? Now, I can put in the address according to the tutorial that supposedly you've done at this point in time. So either you're an Excel expert or you've gone through the tutorial, the pages 1 through 9.5 or 9, sorry. And you know how to do this. Now, one way to put in these is to click here in the number and then drag down throughout that whole series and select them all. And then return. Or I could just, it won't let me out of it now. Okay, so I'll return. And so that now it does it all automatically. And I have all my numbers calculated, and it didn't take me any time, and I didn't have to do it with the calculator. And it's awesome, right? And I can do this another way. I'll show you with 1 over concentration. I could do equals again, and then I'm going to put 1 divided by, and now I have to put in that number instead of me putting in the address, which is B6. I could just click on that and it puts it in for me. And then I could return and it does the calculation. Now, to do the other calculations, the other way to do this is to click in this box where the formula shows up in the formula window, and then take my cursor and change that cross into a solid black cross when I put it in the corner of that block. Click, left click, and then fill down. And I can do that, and it'll do all those calculations for me, and it saves me a whole bunch of time. And now I've filled out those columns. Any questions on that? All right, so you guys are probably Excel experts. Google Sheets or whatever, I hear do the same. I don't know, I've never used them. And if you want to use them, that's fine. It doesn't matter to me. Now, in the directions for number 2, it says these generated columns, these calculated columns that we just did, should reflect the appropriate number of significant figures that they're derived from. So this column here was the concentration column that somebody supposedly did an experiment. So you have to trust that that experiment was done properly, and these are the proper number of sig figs. So you see, I got 5 significant figures here, but here I only have 3 significant figures. That's right, that's 3. Remember the character and the mantissa. The character doesn't count. The mantissa is the decimal holders. So there's 3 places. This value has 3 significant figures. That's no good. I need 5. And in fact, I need 5 all the way to here. And then it goes down to 4. So I need to change this by selecting, going over here and adding another sig fig, or 2, actually 2. Now that has 5 significant figures because it has 5 places in the mantissa. And that reflects the values that it's derived from. Same thing over here. I got to make sure these have 5. 1, 2, 3, 4, 5. That first one's good, but this guy isn't. So I'm just going to make sure that they all have the same number, which is 5. 1, 2, 3, 4, 5. Now they have all 5 significant figures all the way down to that value where it changes from 5 to 4. Now these need 4 sig figs, so I have to select those. Now they have 4 significant figures, And these guys, 1, 2, 3, 4, 5, have 5, so that's too many. I have to go down to 4 here. And now my generated data reflects the appropriate number of significant figures. And I'm done number 2 in the assignment. Any questions? I don't have to worry about scientific notation because these numbers are in the range that it doesn't matter how I present them. Okay, no questions so far, so we can go to number 3. Number 3 says print a copy of the completed spreadsheet, which includes the data calculated. So it's just this right here, just print it. Well, you don't have to print it because you're going to be uploading this. So just save this page to be uploaded in your report. So number 3 is done. Number 4, print this, but with formulas. Again, you don't have to print because you're going to be uploading. So save one of these pages like this, and then go to formula, show formula, click this button, and it changes those values into formulas. Now this one doesn't have all the formulas for my log because of the way I did it. I can go back and fix that real quick though. Let me show you how. I wonder if that's going to mess up my formatting. Oh no, it just messed up everything. All right, I'll fix it. Equals LN. No. Now I'm really messing this up. Okay, and when all else fails, just get out and redo it. Spreadsheet. Okay, so the reason why it didn't come out that time is because I didn't put the formula in for each one. Oops. Okay. You can see how awesome this program or how powerful this program is because it does so many calculations. And when you take a lot of data, like you will in Chem 201, then a spreadsheet like this comes in handy so you don't have to punch all these numbers in your calculator. But anyway, if I want to show the formulas now, I can go to formulas and click this key over here, show formulas, and it'll show me all the formulas. And I can see how that formula changes relative to the line. So if I go down the line, B goes from B7 to B8, B9, B10, and so forth. And so you're going to want to save this and add that into your report because it shows the formulas.
I'm sorry, can you show how to show the formulas one more time?
Yeah, sure. You go up into here, go from home to formulas, and then you click on show formula. And I believe this is in the tutorial. So if you go through that tutorial, you'll learn it there too.
Thank you.
Yep. Any other questions? All right. Let's fix these real quick. Fix these again. All right, good. Now we're back up to snuff and we are done up to number 4. So all we have to do is 5.
I got
6,
a question,
7.
Professor.
Yeah, go ahead.
Why is the 1 over m like from 19 down is like 4 figures, and then the other ones are 5 figures?
Because this is the experimental data.
Oh, okay. I see.
Somebody went to lab and they took that. So we have to assume that they did everything right. And in the experimental procedure for the first 12 items that they noticed, they were able to get that many sig figs, but then after that, they lost a significant figure.
Okay.
Whatever they were doing, you know, the concentration went down and you lose a sig fig. All right, good question. Any others? Okay, so we're up to 5. Okay. So in the instructions for preparing your report, number 5 says construct a graph of concentration versus time and print it out as page 3. You're not going to print anything out. It's all going to be uploaded. It should be properly titled and labeled according to, you know, what you learned in the tutorial. It should have the appropriate number of significant figures and so forth. So I want to show you how to make a plot real quick. What I usually do is I select the columns that need to be plotted. So I'm going to do a concentration versus time. The x-axis is first, goes X, then Y. And now I'm going to go to insert, scatter plot. And that's it, done. I got my plot. There's my first plot. I can put the title over here that's appropriate. Edit that title to concentration versus time. And if I want to add in titles for the axis, I can do that. Over here, I have concentration, and from doing the tutorial, I know that whenever you add titles, it should be the title and the units are in parentheses. So concentrations in molarity, so M, like that. And down here I have time, T, in units of seconds. Okay. And so now I have a nice properly labeled plot with the appropriate units. And I can check to see if the number of significant digits on the axes are appropriate. I have for concentration between 4 and 5 sig figs. And that's what my concentration is, 5 down to 4. So that's good. Time looks like I got 2 sig figs, and time, oh, I didn't change the time to reflect between 2 and 3. So I got to do that because I went back and changed it for okay. Now, as soon as I changed the number of sig figs here, notice that it changed on my plot. to reflect the appropriate number of sig figs. So Excel does this automatically. They just want you to check in your report to make sure you see that. So now I see that the number of sig figs on the time axis is between 2 sig figs and 3. And that's what I have over here, between 2 and 3 sig figs for time. All right. So far, so good. Any questions? Okay, so it goes on in number 5. It says, if there's a linear relationship, then they want you to tell Excel to fit that to a line and display the equation of the line on the chart and make sure that you modify that equation so it's appropriate to the plot. That's all in number 5. But it's not a line. It's not linear. You can see it's definitely curving, so I don't have to worry about it. So 5 is done. We go to 6. 6 says construct the plot of the log of concentration versus time. So I'm going to do that one now. Time is the x-axis. So I select that. And I want the log of the concentration. Now I gotta skip that concentration column to get over here to plot that. To do that with Excel, you can press on your control button and then click and select that, and it skips the column. Okay, then I let it up, and then I go over here to insert scatter plot, and there I have my next log of concentration versus time, and you can put in the titles appropriately. So that'll be good when you finish that. And it wants you to do the directions in 5, and the 5 directions say if it's trending linearly, then tell Excel to find the equation of the line, and it is. So I know from the tutorial how to do that. I pick any one of these points, I right click on it, and I go add trend line. So this thing pops up. I pick out of my lines that I want to add. I want a linear, and I want, see, I want to display the equation of the line. So I'm going to click that button here. And I want the R² factor, which is a goodness of fit criterion. The closer that number to 1 is, the better the line is to linear. And so it gives me the equation of the line right here. And it also says in number 5 that I'm going to need to format that equation appropriately to go along with the plot. So what's my y-axis for this plot? I know I haven't properly formatted this plot yet, but I know that it's the log of the concentration. So I'm going to take out y, and I'm going to put in log of concentration. And it doesn't have units, because whenever you take the log of something, it's unitless. So now I go over to the slope, because I know an equation of a line is y, which in this case is the log of the concentration right here, times that equals y equals mx plus b. So m, the slope, is minus 0.0714, and that has units. So I got to put the units in there. I'm going to put them in parentheses of y, change in y over the change in x. Y is unitless, so there's no units in the numerator. And the x units is seconds, so it's 1 over seconds are the units for the slope. For x, well, that's just time. So I delete X, and I put in T for time, and I put in seconds in parentheses for its units. And the intercept, which is 3.2439, is unitless, just like the y-axis. And this is true for any equation. Any equation has to be consistent in terms of its units. In other words, each term in the equation has to have the same units. Apples equals apples. Apples do not equal oranges. So y has no units. Mx, when multiplied, should have no units. Let's check it out. So let's see if this term has no units. The slope, 1/seconds, times x, which time is in seconds. So the seconds cancel, and sure enough, that term is unitless, and the b is also unitless. So the equation's consistent. It's good. And you should look for that in any equation anytime you have one. If you don't have consistent units, then there's probably something wrong. All right, so you want to put the chart title in here too, log of concentration or something like that versus time. There it is, log of concentration versus time. And you can add your axes titles here and here, just like we did up there. Make sure you did it the same way. And the last thing it wants you to plot to do the same thing as in number 5 for number 7 is again plot time, but this time 1/, the concentration. So I got to control and select that. I just noticed that this one time is screwed up as far as sig figs. But anyway, I'm going to insert a plot and generate my last plot from the data. And you can do that and properly title it. And you don't have to fit it to a line because it's not linear. It's definitely curvature. Any questions on this? Okay, so we're good. All right, then that covers 1 through 7. I want to stop there and save 8 for Monday. I'm just gonna hang out in case you guys want to ask me some questions, but we're pretty much done for today's meeting.
Cool, thank you.
Thank you, guys.
Thank you.
You got it.
Thank you, Professor. Have a
Thank you,
great day.
Professor.
Okay,
Thank you, Professor. Bye.
bye-bye.